Everyone, January the 1st. Alright, let's get right into it. Convert an array into a 2D array with conditions. Alright, let's do a Java on this. You're given an integer array nums. You need to create a 2D array from nums, satisfying the following conditions. The 2D array should contain only the elements of the array nums. Each row in the 2D array contains distinct integers. The number of rows in the 2D array should be minimal. Return the resulting array. Multiple to any one of them. Note that the 2D array can have a different number of elements on each row. Create a 2D array from nums. The 2D array should contain only the elements, okay? Each row contains distinct integers. Number of rows should be minimal. Okay, so we can do a counter. All right, so 1 appears 3 times. So because each row has to have distinct integers, the 3 ones has to appear in 3 rows. And then we go to the next one, 3 and 2, and 4 can put in whatever, 2 put in whatever, yeah? Yeah, this is not hard. Okay, so number is smaller than this, so I just need to count. No, I don't need to. I do need a counter. 200, 201, because the largest is 200, right? Then we say for int I, we can probably do this, right? Oh, we need a what we call it res. Right? If counter n is equal to 0, hold a second, what should we do? Plus plus, right? So we say counter n plus plus. Okay, and then if res dot size is smaller than n, then counter n, right? Counter n how many? So I have 1 smaller than that, then res dot add new array list. Okay, then res dot get counter n dot add n. Return res. That is interesting. Probably have to do the -1. Yeah. Since each row must contain distinct the each integer, each copy of the same integer must occupies a different row. Thus, we can keep a counter of each integer and add a new row to the result when there are more copies of an integer than the number of rows. O(n). Okay, let's try this. Okay, not bad. Frequency counter. Oh. Shit. Yeah. Faster. What the hell? I have no idea what happened. That was scary. Okay. Apply operations to make all elements equal to 0. You are given a 0-index integer array nums and a positive integer k. You can apply the following operations on the array any number of times. Choose any subarray of size k from the array and decrease all its elements by 1. Return true if you can make all the elements equal to 0 or false otherwise. So basically we're saying we have to choose a subarray of size k and then decrease every element by 1 any number of times. So the first one is true because I can pick this, get everybody to 0, this will to 0, this will be to 1. This has to choose size of 2. I see. Interesting question. I think we can just sliding window this and just see if it's possible. You know? Hold on. So what I'm thinking, because if it's possible, then you have to do a subarray and then do the minus on someone, right? On some of them. It doesn't really matter if which one you do first, which one you do later. That's kind of my idea. It doesn't really matter because if it's possible, does it matter if I do it? You know what? That's not true because if I hit these first, right? If I hit these first, that become a 1, 2, 0, then we're screwed. So there is a best way to do it, but to reduce the first one to 0, we have to get to the first one. So we have to do the k, right? Starting from the first. right? We have to do the first, and then we get on to 0. And then once that one is done, then we have to do the second one. Yeah, that actually makes sense. Because otherwise you cannot hit, like if it's possible, there got to be some way to handle the first one. You can say something in the middle, like there are many different ways to include it, but the one in the front, there's only one way to include it. And then you do that, right? And then you get down to 0. And then you'll have something else. Yeah, so we get onto 0 and then move. I think that's correct. But we need to try it. Prove me wrong. Prove me wrong. I think this is right. Simply because once you get the first one into 0, then the new one, yeah, becomes 0 as well. So how am I gonna deal with this? We just find the values the same, right? The same. And the first one that's not the same. Huh. So same. Hold on. It's not that simple. So you get the first subarray, right? The first subarray. And then the subarray, what if the second value is bigger than the first value? And the second value is smaller than the first value. Then we're screwed. Right? Then we're screwed. So, So we take the first k, right? So within the k, within the first k, it has to be non-decreasing. Because if the first k, you have a valley, then it's just not possible, right? So the first k has to be non-decreasing, which means the first one must be the smallest, right? So we take the first one, we go to the first k, and then we do, minus, and then we see if everything works. Then we'll get the new value, right? Then I'll get the new value, but you get the new value. Sliding window. Go to the front, we get to the end. We go through the whole thing, right? Make sure it's non-decreasing. Okay, it's non-decreasing, and then we minus this, right? We minus this value, and then we get to this. We go to the first thing, so we get a first value. Okay, and then like within k, we go, the first value should be the minimum, right? And each one, the first one that's not 0, that's larger than 0, we record it. Okay, we record it, and we know its position. And then go to the last one we recorded as well. And then what? And then you try to extend. Okay, so you have this is k, right? And then let's just say they are non-decreasing. Okay, and then you go from here, and the first one, that's so you get, let's say, n1 minus n0. So this is like the new start, right? This is like the new start. And then you have to start go from here. Go from here. That's not right. It's not the spirit of how to deal with this. All right, let's go back to the front. So from n0, right, the first one, we know that to make this one 0, it must, no, the first k need to minus n0, right, minus n0. So I go through every single one, okay? And as I go through every single one, can we make something happen? I mean, I can create a new array. I mean, if it's 0, it's just ignored. If it's not 0, then we have a new one, right? Then we have a new one, new one, new one. So after we go through this k, we have a new array with new values, okay? I will know all these values, and then I have new ones coming up. And I know this one, so I say, okay, I know how much to remove. But then the problem is, I need to create this one, right? And to create a new one. That become O(n) squared, and that is not going to be right. But hold on, all you want to do is to see if it's possible, right? Whether it's possible or not. So what type of condition will make it impossible? Well, make it impossible is when it's not non-decreasing, right? Whenever it's not non-decreasing, like in this case, -1 is becoming 2. 2, 1 is decreasing, so that's why it's not possible. Which means within the k, right, I need to tell if it's non-decreasing. So I go through the whole thing, and it is non-decreasing. So the first one's good, right? And then, because the first k is good, we know that after we remove n0, everything will be non-decreasing as well, right? Therefore, all we want to know is the last one, because the last one is the biggest one, right? Because all of this is going up. So I know the last one. All I need to compare is the last one to the next one, because this is the biggest. If this is larger than the biggest, everything's fine. Therefore, I get k, right? I go through k, make sure everything is good, right? Make sure everything is good. And then I do this nk, I do nk minus n0, which is, after we remove the first subarray, the biggest value in the next round, okay, in the next round. And as I go through, I can, okay, that is cool, right? So I know this, I just need to compare to the next one. So with that, I will be able to determine if it's still non-decreasing. Okay, cool, that's fine. But I do need to have 2 point. We have 2 pointers, right? We have one is here, go all the way here, go to here. Okay, everything's fine. So that's the first K. And then I go from here, so we move to the first one that is non-zero. Okay, so by that, I know how much to move this forward, right? And then as I move this forward, I'm checking. Is this larger than this? Is this larger than this? Everything should be larger than the one previous, right? And done. So now point to the new one. So it's the next K, everything's fine. And then I'll move this one forward. This sounds doable. This sounds doable. So, okay, let me do it one more time. Okay, so first things first, I will go through the first K, okay? I go through the first K. I wonder if it's possible for me to, yeah, maybe I can, so, okay, so 2 pointers, right? Both pointing at this one. And then one of them starts moving. Every time move, I need to check if it's good. If it's good, good. And then we move to the last one. Everything's good, right? So that's kind of move, extend to the right. Then we will shrink from the left. And by shrink from the left, we just, minus, I think I will change nums in place. I'm sorry, I have to do that. So we move from the left, this will become 0. And then we check, so we go to the first one that's not 0, right? And then we all modify this, and then, okay. This looks promising. Oh, I already opened it. Okay, this looks promising. Whew. So we'll have, let's call it I and J, okay, for I. Which one keeps moving to the right? Yeah, you know what? I don't know. Does I always move to the right? Let's first round just do this. While what's the end? Well, the end is J hits the end, right? And then I will start to move. And yeah, good question. What is the end? And J will always move to the size of K, right? Right, we move J to size of K, and then I will move forward until I meets J. And then I will go beyond J, because I need to move to the next one, right? I go. It's kind of like a reset. Oof, kind of a reset. Okay, how about we do this? How about we do I smaller than n and j smaller than n? Nope, I think it's a or. Okay, and then first thing is I will move j, extend j. Okay, then we say while j minus I plus 1 is smaller than k, right? Oh, that's interesting. Do we move j beyond? You know what? Maybe we should. Maybe we should. Maybe we do this. So start I is 0, so j will move to 3. Right? J will move 0, 1, 2, 3. J will move to 3. So j will be pointing to the next one. Okay. So while this, right, we say if nums j is smaller than nums j minus 1, right? Because I'm extending j to the right. And if this one is not non-decreasing, when this happens, we'll return false. What about the start? You don't have j minus 1. Good point. Good point. Maybe when we start, we go maybe j plus equal to 1 every time we start to make sure that we can do the comparison. Okay, maybe j plus equal 1. So we start with 0 and j plus equal 1, j always pointing this. And then we say j minus I smaller than k, yes, because that's 1. And then we say nums j is smaller, no. And then otherwise we say j plus equal 1, right? So j move forward and we compare it again because it's 0, 1, 2. That's 2 smaller than 3. And then we compare these two. What's good? J move forward and then 0, 1, 2, 3. And then 3 minus 0 is 3. Okay, so we break out. Okay, so this is when we break out. So basically j is pointing here, right? And then we need to move I, right? We need to move I. Move I forward until we hit a value that is not. Oh, they might hit the same value, man. They might hit the same value. But it's okay. It's okay. So what we want to do is say while I need to be smaller than j, right? I need smaller than j because if I hit j, that's beyond. So I need to smaller than j, and nums I is equal to, oh, I need another one, low, called left equal to I. Okay, if this is equal to nums left, okay, while this is true, then I plus equal 1. Okay, so this I plus equal 1, this I plus equal 1. So the first one is not true. Okay, get out. Then we need to, oh my god, then we need to check. So basically this is smaller than j, right? J minus equal 1. So we need to check if right, if I is smaller than j, if I is smaller than j, which means we're still in the previous one, then what we should do is nums I minus equal to nums left. Okay, so minus equal to nums left That's good. And then we shall say if I is not equal to j minus 1, then nums j, all j minus 1 minus equal to nums left. This is the first number that is, when you reduce it, that's not 0. Okay, this is the last number. But to prevent the case of we're deleting on the same thing twice, we need to do another check. So if we do it once, we don't do it again. Right, so if I will move forward. So I right now, because I is smaller than j, right? I is smaller than j. If I is smaller than j, then we do basically here, right? This will minus 2, so this will become 1. And then I is actually equal to j minus 1, so this one I don't do. So I is here, j is here. Then we go back up, right? Then we go back up. We need to do a check. We shall say if I is equal to j, then j plus equal 1, right? If not, then we keep going, right? If not, like in this case, j will be here, I is here, right? So I is not equal to j, j don't go up, so we do the same thing. We do this, smaller than k, this is smaller than this, no, so j plus equal 1. Okay, j plus equal 1, so j will end at here. Okay, j will end at here. Now left will be here, this one will be 1. I smaller than j, and nums I, yes, 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 boom, I hits here. Okay, I hits here. I is smaller than j, no, I is equal to j, and I is not equal to, this is actually correct. Then I'll do this. This is actually this is not right. Should be more specific. This is not I not equal to. If I is smaller than j minus 1, because in this case I is larger than j minus 1, right? Look at this. This is interesting. I smaller than j. We do this. I smaller than j minus 1. Hold on, I smaller than j means we are on the left hand side, right? And if I is even smaller than, then we do this. What do you think? Can we combine these two? This is more stringent, right? So maybe I can do this first. I is smaller than, if I is smaller than j minus 1, I must smaller than j, right? So if I is smaller than j minus 1, I shall do both. But if I is equal to j minus 1, then I do just 1. How do I phrase it? How do I phrase this? Because j minus 1 needs to be removed as well. So maybe, because j minus 1 needs to be removed, what I can do is I will remove j minus 1 first. How about this? I'll remove j minus 1 first, because this bound to be removed. Right, j minus 1 I need to remove. After that, we say if this is smaller than this, then I remove another one. I remove I. But if I is equal to that, I don't remove again. So yeah, we do this. So at the end, I and j both in here. Right, in this case, I and j both are here. I, j. So count to the next one. I equal to j, so j plus equal 1, so j gets out. Right, and then j minus I is small. Okay, so while j, so this j is smaller than and, so this won't do. So left will equal to I smaller than j, and then go out, and I will equal to j. Come out. And j minus 1. Yeah, this is fine. This is fine. I think this is fine. I think this is fine now. I think I'll return true here. Alright. Does it work? Oh, this probably is. Oh, that's a good test case. Just try it. Ugh. Wrong. Ugh. Okay. I suppose this is one of those problems. Oh, I absolutely hate it. And it's shrink to 3, shrink to 2. Okay, and then remain 4, and then we'll shrink this about half. And I'll do another one. I'll shrink the front about half. And then we'll do another one. Let's kind of shrink in the middle. Okay, let's see. Oh my goodness, all correct. Screw you. All right. All right, let's remove 2. Oh my god. Seriously? Oh, it's especially crafted. Oh my god. It is specially crafted. Can't even remove a single one. Ha! Wow, it's just specially crafted. Alright, if this one is still not good, then we're gonna just go with this. Yep. Screw this. We're gonna go with it. Because I want to know. 4. Expected is true. Very interesting. Nums k. I still think my way is correct. Oh, shoot. All right. K is 4. Right, K is 4. So, okay, let me do this. This is not necessary, but I minus equal to nums left. Okay, let's print nums. You're kidding me. Doesn't sound right. All right, so we're starting from here. Jagan here. Go. 0, 1, 2, 3, 4. So J now is here. All right, okay, let's get. What's J? J is 4. 0, 1, 0, 1, 2, 3, 4. Yeah. Oh, because this, it's... Yeah, let's not do left. Let's just... Yeah, let's do left. Let's do nums I. Okay. Let's do left. And then... do left. Left. Oh. Ooh, that was ugly. We got some negative value going. Oh, because some of them are not. I see. Ah, shoot. Okay, I know the problem. Yeah, we do have to do the minus. Damn. Okay. We need... Shoot. Accumulate. Huh. How do we handle that? You need to accumulate. Yeah, this is not just 75. This is not right. It should be added together. Yeah. But hold on, that doesn't matter. Oh, it does matter. It does matter. Oh, it matters big time. Because we need to know what is... Oh my god. Me god. Just start from the left. Yeah, I start from here and then I end here. 89 minus 60. Yeah, I got 29. So 0 and 29, right? This is the first round. And then starting from this, I'm looking at 12, which is fine. And this minus 12 is fine. But this is not minus 12. This should minus 12 and something else. So I have a certain amount that need to be removed, okay? Then we move on, and we have a new amount, okay? But then the new amount only applies. Oh, then you can, oh, no. Woo. It's all because I need to know how much need to be removed. I start from the front, okay? So I cover the first K. And then I start, I cover the first K and I move forward and I get a new value, okay? Then I start extending. So yes, these extend will be correct. And I stop at a new one, okay? And then I need to move forward. Yeah, how am I supposed to move forward, man? How am I supposed to move forward? When I move forward, the deduction is a combination, right? It's a combination. So okay, I can combine them. I go forward, and then let's say I stop at a certain value. And then I keep moving forward. I don't know. I mean, maybe this is not the right way. I mean, it's like a range, and you do a minus. It reminds me of something. It reminds me of segment tree, right? It's a segment tree, and you can apply the same operation to the segment tree. Use some like lazy propagation, right? Would that work? Would the segment tree with lazy propagation work in this case? I don't know. I think no. A segment tree with lazy propagation is to compute the total sum. The total sum. I mean the total sum, right? This is exactly what we want, the total sum. The total sum should be 0. The total sum should be 0. Alright, this one is harder than I had expected. I gotta sleep on this. Yep, I gotta sleep on this. This is tough. I think I just didn't think in the right way. And the current method I was thinking is non-decreasing. And I'm trying to figure out a way to get it to be non-decreasing, but it's not right. Right? It's not right. Like a sliding window and non-decreasing. And then the problem we have is we couldn't figure out how much to remove. Yeah, and in this case, like we have a negative value. That's not true because this is not supposed to be 75. But we are only focusing on the and the front. but the problem is we don't know, because we know the end, right? Every time we extend and we find the end is fresh, right? The fresh. So all we need to figure out is how can we compute the front. That is the key. We need to know the front. Or we shall say, when I cross, like before I cross a certain index, it should be this amount of removal. After I cross it, it should be a new amount of removal. That is, maybe. That might work. Right? Because all we need to keep track is the beginning, right? So the beginning of the subarray. I need to know the beginning of the subarray because the beginning of the subarray will determine the end of the subarray after it gets removed. The check itself is when we extend on the right. So the check is not affected. The check is not affected by the amount to be removed. What is affected by the amount to be removed is this one, okay? This one is affected. So I need to know left. If I know left, like these doesn't really matter. I don't need to do the minus. If I can know left at every single subarray, I will be good, okay? The reason this is wrong is because the left is wrong. So initially the left is 60, right? And then perfect. This is the start of the subarray. This is the end of the subarray after removing 60, okay? And now when we're done, I will be pointing to this one, right? Pointing to this one. So the new thing to remove is 12. And the end will move forward, right? The end move forward once. The end is just here. And then it's correct, right? The end is here. So now for this is minus 12, which is correct, right? But then for this one, right, this 87, you do not just minus 12, because I will move to this one, right? So I need to minus 12, yes, but you also need to minus the first one. So this shall minus 72. Right? It shall minus 72. Oh. You should minus the value to your left. Minus the value to your left. Because if you go through one round, two rounds, no matter how many rounds you go through, and then the one to your left becomes 0. And if you are always included in those rounds, that means the amount that need to be removed from you is the same as the one to your left. That is an interesting thought. Okay, again, I need to sleep on this, but I feel like that's a breakthrough. All right, I will be here for today. I will see you guys tomorrow. Adios.